Okay, Chapter 1, Section 3, bringing you a very rare outside episode today from my porch. Earth's orbital motion. Here's a question for you. How far does the Earth go around the Sun each day? Each day of the year, how far of our path do we make? Well, if you think about it, there's kind of a logical answer here. The answer is approximately 1 degree. We move about 1 degree of the quote-unquote circle. We don't travel in a circle. It's an ellipse, but it's almost a circle. And we move about 1 degree per day. Think about it. You're going 360 degrees, and it's taking the Earth just over 365 days to do 360 degrees, so that's about 1 degree per day. That, my friends, is not a coincidence. Have you ever wondered why there are 360 degrees in a circle? I mean, that's kind of weird, isn't it? There's nothing that says there has to be 360. Why don't we have 100 degrees in a circle? There's nothing wrong with that. But ancient people, that's where we get 360 degrees from. Probably back in, let's say, the Sumerians in ancient time, I believe it was the Sumerians, realizing that there were 365 days in a year, they made a circle to be 360. Now, why 360 and not 365? Well, that's pretty easy. 360 is easily divisible by a lot of different numbers, including the number 12. 365 doesn't divide up very well. Now, why would the number 12 be important? Well, because of the number of months in the year. So if you have a 360-day year, you can divide it into 12 equal months of 30 days each. How perfect is that? Now, what do you do with those remaining 5 days? You get wasted. That was the solution of some of these civilizations. I'm not making that up. Some of the ancient civilizations decided, we're just going to party the last few days. I'm sure that's what it's meant for. So they'd have their 360 calendar, and which worked out well. Anyway, just some fun facts. Eventually, the fact that 360 became important for that reason also led to the fact that there are, 60 minutes in an hour, for example, and 60 seconds in a minute. All the divisibility into 360 came into play. That's kind of a long history there, but that's where that all comes from. It all goes back to astronomy, I'm telling you. Now, speaking of us going around the sun, there is a group of constellations that we can see all year round. They're called circumpolar. Circum means near, so circumpolar, near the poles. There are northern circumpolar constellations and southern circumpolar. It all depends on where you're at on the Earth's surface. So, for example, there's a small circle of constellations that we can see here in South Florida all year round. There are also constellations at the southern, that would be in southern circumpolar, that we can never see from South Florida. Okay? But again, it all depends on where you live. And if you happen to live on the equator, well, you get to see all of the constellations at some point during the year. Anyway, and if you lived, let's say, at the North Pole, you would only get to see half of the constellations, essentially, or a little more, and you wouldn't get to see a whole lot of the southern constellations. So here, as the Earth travels around the sun, the constellations are out, but they're in the daytime. So if you're on one side of the sun, you're not seeing all the constellations that are out in the daytime at that time of year. I don't know if that makes any sense. So you spin around at night and you see stars and constellations. You spin around in the day and you don't get to see them until the Earth has gone around to the opposite side of the sun. So, for example, here in the northern hemisphere, if you look at the left part of the screen, we have some summertime constellations, Cygnus and Lyra and Aquila. The three brightest stars in each of those forms what's called the summer triangle, something to look for at this time of year when I'm recording here in August. But that means that we're on this side of the sun here in August. We are not going to see constellations that are being blocked by the sun. Those would be the ones here at the bottom right of the screen. So bright I can't hardly see, but I see Gemini for sure there, and Orion and constellations like that. would only be out in the winter. And guess what? When it's winter time, when we spin around at night, we see Orion, we see Gemini, but when we spin around in the day, you're not going to get to see those constellations. You're not seeing, Cygnus anymore at that point. So that's kind of how that works. Now let me show you some that are circumpolar in the north. Now these are ones that are around Polaris, the North Star. Let me see if my little pointer here, oops, if I can use the pointer perhaps. Oh, there it is. So there's Polaris. It is the tail end of the Little Dipper, which is part of Ursa Minor. And then around it you have constellations like Cepheus and Cassiopeia and Draco, which, at least from my latitude, can be seen all year round. Sometimes they're higher in the sky than others, but still you can see them. And you notice the Big Dipper, it's pretty close to the pole as well. So for a lot of latitudes, the Big Dipper, aka part of Ursa Major, it can be seen year round as well. As I mentioned, though, in the south, there are other constellations that we never get to see in the south. Now, one big difference is there's no south star. There's no particularly bright star that's due south in the southern hemisphere. And I'll tell you how, the North Star was so important to sailors and so forth hundreds of years ago. And I'll explain how you find your way south in the southern hemisphere. First, here's a picture I took one night in Peru of the Milky Way. And here's one I took in Chile just a few weeks ago. And one of the things you see here, this is at the CTIO, Cerro Tololo Inter-American Observatory. And that smudge right there is the Large Magellanic Cloud, something you can only see from the southern hemisphere. And it really stands out. You can just see it with your eyes. It's really neat. It's kind of a satellite galaxy of our Milky Way. It orbits our Milky Way, but it's considered to be a separate galaxy. Here you can actually see the large and small. That smaller smudge is the Small Magellanic Cloud, named, of course, by Ferdinand Magellan. And then here we have a picture. This is from my buddy, Mr. Simpson, and you can... you're looking at the two bright stars at the bottom are Alpha and Beta Centauri. They're part of a constellation that stretches over here called Centaurus, a southern constellation. And then you have something famous there, right there. 1, 2, 3. You see those four bright stars very close together. They form the famous Southern Cross. The famous Southern Cross. The actual constellation name is Crux, C-R-U-X. And one way there's another cross of stars in the southern hemisphere that they sometimes call the fake cross. And the way that you know it's the real one is that it has the fifth star that I circled there on the screen that you can see. That fifth star. So let's see if you can spot it here. Here's another one of Mr. Simpson's pictures, it looks like. All right. Check this out. So the Southern Cross, very popular in southern hemisphere countries for their flags. And you notice that it looks like, I think it's Australian flag has that fifth star featured, but New Zealand decided they're just going to put those four. Kind of interesting. One that you may not have ever noticed before, I always love the Brazilian flag. It looks really cool, but if you look in the center of it, you have a lot of constellations on the Brazilian flag, which is really cool. I believe, if I remember right, the number of stars represents the number of states or provinces or whatever they have, and you'll see the Southern Cross there featured right in the center of those. Pretty cool. There you see where the South Pole would be, the South Celestial Pole. No bright stars over there, but you see the Magellanic Clouds there. Canopus there, one of the brightest stars, I think the second brightest star in the entire sky. A southern hemisphere star. All right. So let's talk about something that's a bit tricky, the ecliptic. If you trace the sun's path through the sky, let's say that the sun somehow left a trail as it went through the sky during the day. Now, obviously, we know that's from the Earth turning. Okay, when I say the sun moving through the sky, you know what I mean. If we traced its path through the sky and then went out at night and that path was still glowing, we could still see it, that would be the ecliptic. Now, the reason there's a flat path like that through the sky is because our solar system is flat. So the Earth's orbit around the sun and the planets, their orbits are fairly flat. And so the sun's so-called path through the sky, which is really the Earth's path going around it, is called the ecliptic. And guess what happens only when the sun, the Earth, and the moon are all exactly on the ecliptic? You guessed it, an eclipse. So that's where it gets its name from. Anyway, so ancient people, of course, thought that the sun was traveling through the stars. Now, how many constellations does the sun pass through? Well, technically 13. A lot of people, maybe you've heard of that famous 13th sign there. That's called Ophiuchus. But anyway, 12, again, being important because of the number of months of the year. Ancient people wanted that to work out, and that's where the whole zodiac came from, the idea that each month would have its own constellation, because that's where the sun, they thought, was traveling. Remember, it's based on what they thought the sun was traveling through at that point. So that's why the 12 were special. They're not the brightest stars. They're not the oldest. There's nothing that unites the zodiac signs other than the fact they're along the ecliptic. They're along the path of the sun. And ancient people figured out exactly where the sun would be traveling each month of the year. Here's where things get, I think, surprising to people. If you go out on your birthday and you say, oh, I'm a Gemini, or I'm a this, or I'm a that, and you think you're going to go out at night and see your sign, you're not. Yeah. Because check this out. If it's your birthday, you can only see your zodiac sign at night, right? But the zodiac is based on where the sun was at. So your sign, your constellation sign, is actually out during the day on your birthday, meaning you don't get to see it. Yeah, it always surprises people. The best time to see your constellation is on your half birthday. So if you look at these pictures here, so let's say it's May and you're a Taurus, for example. You go out here in May and you spin around at night. And remember, ancient people realized, the sun's traveling through Aries and Taurus in May, but you turn around at night and you're seeing, Scorpius and Virgo and constellations like that. So it's the opposite of what you think. It's always surprising to a lot of the students. Okay. Yeah, these constellations have nothing in common. It's pretty fun to study them. You have ones that have no bright stars, like Pisces or Cancer the Crab. You have ones that are old, like Pisces, that are very ancient constellations. And you have some like Libra that's actually just maybe 100 years older. So fascinating stuff. So anyway, but that's just what they have in common. And actually the whole history, it's way too complicated to get into how all the different ones were named, because they came from different time periods and different civilizations and everything. But it's pretty interesting. All right. Well, one group that really changed everything were the Greeks. The ancient Greeks were the first ones to start what you would call like a personal horoscope. They changed things. Up until the Greeks, every city-state or empire, yes, they would pay attention to the skies, and they thought that it had meaning. But the meaning had to do with, like, let's say, the king or the entire country. So the king might ask his advisor, hey, is it a good time to go attack this other group? And they'd look at the position of Venus in the sky or whatever and say, okay, yeah, let's go attack. But the Greeks changed it, and they made it personal. They gave you your own personal horoscope, I guess, based on when you were born and what the sky looked like and whatnot. I always get upset when people say that, oh, you teach astrology. No, I don't. Not at all. I teach astronomy. Astronomy is a science. Astrology is a belief. And if that's what you want to believe, that you're absolutely welcome to believe that the stars affect your life or whatever. But that's not astronomy. Not at all. Astronomy is a science based on observation and so forth. So anyway, I think that's about it. for section 3. Thanks for listening.